Warm salutations, welcome to a nostalgic math chat, and let's get ready to ramble. So today we're looking at the department's May 2023 paper 2, question 5.4, which is giving trig identity flavors. Let's get into it. Consider cos of 2x plus sine of 2x minus cos squared x divided by sine x minus 2 cos x, whoa, a lot going on, is equal to something so cute and simple, negative sine x. And we are asked to prove the above identity. Okay, so sometimes it does, I find it a bit tough to figure out which side to use as my starting point in terms of like trying to prove the identity. But in a situation like this, it's quite straightforward to see that, okay, left-hand side is the more complex side. There's a lot going on. So I'm going to use that as the side that I want to simplify and show that, okay, upon simplification, it ends up simplifying to negative sine x. Okay, so I see that on my right-hand side, it's just speaking in terms of the angle x, whereas on my left-hand side, there are two ratios that are referring to 2x. So that immediately kind of hints to me that I need to express those double angles in terms of x rather. So let's not talk in terms of 2x, let's talk in terms of x, and let's see how close that gets us to the finishing line. So left-hand side, this is question 5.4.1. Okay, so the left-hand side is cos of 2x plus sine of 2x minus cos squared x divided by sine x minus 2 cos x. So the bottom, I'm just going to leave for now. Hopefully we'll get opportunities to cancel later down the line, but for now my priority is to deal with the ratios that are speaking in terms of 2x. So I'm going to bring out I'm going to rewrite this guy using the cos squared x minus sine squared x. Okay, so that's me replacing this guy. Okay, the sine 2x, I mean, okay, there's only one way to write that. That is 2 sine x cos x. Okay, so that's easy enough. So let's just highlight that is that. Okay, and then this one I'll leave this way for now. And we're already seeing opportunities to cancel over there, so that's cool. And the bottom will just be sine x minus 2 cos x. Okay, right. Then, indeed, we can cancel Lulu. So this guy minus that guy results in a 0. Okay, cos squared x minus cos squared x is 0. So then all we're left with at the top is negative sine squared x plus 2 sine x cos x divided by sine x minus 2 cos x. Okay, and so I can see a common factor that I can take out. This has sine x times sine x, this has a sine x, so we can factor out sine, and in fact, okay, so let's just see here, let me not jump the gun. So then I'm left with negative sine x, and here I'm left with 2 cos x. So this is the gun that I wanted to jump ahead of, right? So we can now see that there's something similar about these two, okay? But the difference is that this is a positive sine x and a negative 2x, whereas here we've got a positive 2x and a negative sine x. We've got the signs the other way around. So I can then, instead of factoring out a positive sine x, I should factor out a negative sine x. So then here I'm left with a positive sine x, right? So then timesing these gives me minus sine squared x, okay? And then this would have to be a negative 2 cos x so that I can get a positive up there. Right, so then we can treat this as 1 times that bracket, right? So that we can see why it's actually legal for us to cancel those two, right? Good and well. So this just remains as negative sine x over 1, which is just negative sine x. And this is what we had set out to prove. So we have ended up with negative sine x, which is awesome, right? So this is indeed equal to the right-hand side. Okay, awesome sauce. I can't immediately see another way that we could have done that. So good on us. I guess, yeah, if you had decided to use the 2 cos squared x minus 1 to replace this guy, it would, that would have been interesting, because then you would have still had a cos squared x left, and then, that would have been, okay. I am content. If you want to experiment with other ways of doing it, knock yourself out. Knock yourself out, kid. No, really, knock yourself out. Really go for it. I thoroughly encourage those kinds of explorations. Okay, so now let's look at 5.4.2. Okay, I want to crop that. Oh, maybe not. Yeah, maybe let's just hold on to both. But definitely crop it up there. Oh, what just happened? Oh, oops. Okay, right, so that's fine. Okay, so let's look at the next question. So we are asked to determine the value of cos squared x plus, not cos squared x, cos 2x, cos of 2x plus sine of 2x minus cos squared x. So far, that looks like that. Okay, and in the denominator, we have negative 3 sine squared x plus sine 6 sine x cos x. Okay, so that looks a bit different to the denominator that we have started out with. Okay, so my instinct is to figure out how to get this denominator to have some kind of relationship with that one. So is there a way that I can express this denominator in terms of that one? Because then I can manipulate this guy accordingly. I know that sounds very abstract, but let's see if we can. So I'm just going to say minus 3 sine squared x plus C6 sine x cos x. Okay. So if I look at the difference between this guy, and I'm not saying difference in terms of minus, but in a very informal way, the difference between those two is this is sine x times negative 3 sine x, right? And if we look at the difference again, not in terms of minus, but in terms of how do I get from here to here, it's also a situation where we're timesing by 3 sine x. So that hints to me that, okay, let me take out a common factor here of negative 3 sine x. So first term I'm left with sine x. Second term I'm left with minus 2 cos x, right? And suddenly we're seeing, okay, sine x minus 2 cos x, sine x minus 2 cos x. So essentially what we have uncovered is that cos 2x, there's going to be a lot of writing here, so bear with me, plus 2 sine 2x minus cos squared x divided by negative 3 sine squared x plus 6 sine x cos x is the same as 1 over negative 3 sine x times our original expression, if we can call it that, cos 2x plus sine 2x minus cos squared x divided by sine x minus 2 cos x. So in other words, the top is staying the same, right? It's the same on both sides, so it's just times by 1. But the bottom gets times by negative 3 sine x to get this expression instead. Okay, so what that means, since we've shown that this is the same as negative sine x in the previous question, that means this is just the same as, I'm just going to make the fraction negative because positive divided by negative is negative, times negative sine x. Okay, right, so that is the same as negative, well, negative times negative becomes positive, so those will cancel out. So we just have sine x over 3 sine x. Okay, and again, some more cancel lulu, right? So sine x goes in itself once, goes in there once. Okay, so that just ends up being 1 over 3. And again, absolutely something you can check, right? So we have shown that pretty much for almost all values of x, if I put x in here, okay, I'm going to end up with a result that is the same as putting x in here. Okay, and you can test that with any x of your liking. Interesting exercise would be to say, well, for what x values won't that work? And the hint is, well, for which values of x is that denominator 0? Because we know that we can't divide by 0. Right, but that's a tangent. So in the same breath, what this question has proven is that if we choose almost any value of x, okay, so just being careful of that division over there. If we choose almost any value of x and we put it into this expression, we are always going to end up with a third. So actually this is just so cool and I want to try it out. So let's choose x is equal to 110. So we will then have cos 110 times 2. So the 110, 2 times 110, okay, and then we have plus sine of 2 times 110 minus cos of 110, and we square that result, okay, divided by negative 3, and then sine of 110, you square that, plus 6 sine 110 times cos of 110. And number crunching, number crunching, number crunching. Don't let me down, Calci. You can do it. I believe in you. Yeah, guys, Calci is really stuck, eh? Okay, it eventually came back with 0.333 recurring, a third. Awesome stuff. Okay, don't give your calculator hernia like that in your exam. That's that for this question.